Welcome to Lesson 3 in Session 2, Solving and Graphing Absolute Value Equations and Inequalities. Absolute value represents a distance that a number is from 0. Because it represents a distance, the absolute value of a number will never be negative. Absolute value is noted by parallel vertical lines wrapped around an expression. Here we have the absolute value of 3 is equal to 3, and the absolute value of negative 3 is equal to 3. Now this is true because both 3 and negative 3 lie exactly 3 units from 0. We'll start with absolute value equations. And we know that absolute value must be equal to a positive number. What we don't know is if the expression inside the absolute value signs is positive or negative. So we have to solve for both scenarios. In our first example, we have the absolute value of x plus 3 is equal to 5. Now the expression x plus 3 could be equal to positive 5, or it could be equal to negative 5. So we have to set up for both scenarios and solve as well. So to solve for these equations, we subtract 3 to both sides. So the possible answers for the example is negative 8 and 2. In our second example, the absolute value is getting multiplied by negative 2. So we have to isolate the absolute value first. Keep in mind, we cannot distribute into or combine like terms from outside to inside an absolute value symbol. So we have to isolate the absolute value first. So we do this by dividing both sides of the equation by negative 2. This will isolate the absolute value, leaving us with the absolute value of x minus 9 equal to 7. Now we have the opportunity to separate and set up both scenarios. One scenario to represent x minus 9 equals 7, and the other for x minus 9 equal to negative 7. Adding 9 to both sides gives us values of 2 and 16 for solutions to this example. Moving on to absolute value inequalities. An absolute value can be used with inequalities, and we have to continue to take into account both the positive and negative scenarios. In addition, we must remember that, as stated before, if we multiply or divide by a negative number, we have to flip the inequality. Absolute value inequalities can be split into two cases: a conjunction, often referred to as an AND compound inequality, or a disjunction, often referred to as an OR compound inequality. We're going to start with a conjunction. A conjunction is an absolute value inequality expressed using a less than or equal to sign. A conjunction always ends in the form A is less than X and X is less than B. The solution of a set of a conjunction will always lie between the two critical points. Here's our two critical points, A and B, and we have a solution set that lies in between those values. So our example of a conjunction, we have the absolute value of x is less than 3. Now we know it's a conjunction because we have an absolute value inequality using a less than symbol. So we set up and solve a conjunction. So we put the negative 3 on the left is less than the quantity of x plus 5, which is less than 3. We're now ready to solve, so we subtract 5 to all three sides of the inequality, isolating the variable, giving us negative x is less than x is less than negative 2. Negative 8 and negative 2 represent our critical points. We're going to place open circles at both critical points, and our solution set's going to lie in the middle. Now we have a disjunction, or an OR compound inequality. A disjunction is an absolute value inequality expressed using a greater than or equal to sign. Disjunction is always in the form of x is less than A or x is greater than B. And the solution set of a disjunction always lies outside the critical points. Here's your critical points, A and B, with your open circles. Now the value of x is going to be less than A, and the value of x is going to be greater than B. For our example of a disjunction, we recognize it's a disjunction because the absolute value of x minus 2 is greater than or equal to negative 7. So you have an absolute value inequality expressed using a greater than or equal to sign. We have to recognize that as a disjunction. So we set up two inequalities. X minus 2 is less than or equal to negative 7, or x minus 2 is greater than or equal to positive 7. So we set up one inequality for being less than or equal to the negative, and the second one for being greater than or equal to the positive. Adding 2 to both sides solves the inequality and tells me that x is less than or equal to negative 5, or x is greater than or equal to 9. Now when we graph, we drop our critical points of negative 5 and positive 9. We're going to have closed circles at each point, and we're going to shade on the outside. So the values of x are less than negative 5, or the values of x are greater than 9, greater than or equal to 9. So that wraps up the lesson. To earn credit for completing this lesson, you must successfully complete the quiz. Good luck.